So first we're going to look at a problem where we could use law of sines to find the angles. In DEF, F equals 4, E equals 3.2, and measure of angle E is 7. So we're going to draw that out. E is 7 degrees, side E is 3.2, and we have D and F. So F is 4 centimeters, and we're trying to find the measure of angle F. I'm just going to put an X there. I could put an F there. So because we have that pair, we know we can use law of sine. So this is going to give me 3.2 over the sine of 7 equals 4 over the sine of x. So you'll see the x ends up being with the sine value because we're looking for the angle. And this just came from, if you remember the law of sines from yesterday or from the last lesson, right? We have a over sine a, so here's a pair, and then b over sine b, so there's another pair. So when I start to solve this, I get that 4 times the sine of 7, if I cross multiply, equals 3.2 times the sine of x. Then we're going to divide by 3.2. So making sure I'm in degree mode is always for these problems. If I type that side in my calculator, I get approximately 0.152. And I'm keeping that whole decimal in my calculator equals sine of x. Now that you've learned the past few lessons before we started law of sines and cosines, whenever you get to an equation like this, you really can't be ignorant of the fact that we have to think about the fact that sine is positive here. So we could have answers, if sine's positive, we could have answers in the first and second quadrant where sine is positive. So I'm going to do sine inverse of 0.152 to solve this, and that's going to give me an answer of 8.8 degrees. So I have answers in quadrants 1 and 2. Quadrant 1 is 8.8. Here in quadrant 2, 180 minus 8.8. I'll write that down. Would give me 172.2. So the question is, how do I have two answers for the same angle in the triangle? Could I use both of them? Is one of them the right answer? So if I look here, if I put the 8.8 right here, I mean, it looks kind of weird, but that would fit, right? 7 and 8.8 degrees can fit in a triangle. If I put the 172 here, I mean, it's pretty close, but that also fits. I just have to have a really tiny angle here for D, because 172.2 plus 7 would equal 179.2, so there could still be a 0.8 degree angle there. Now, the reason we're not doing these problems, this is something special called the ambiguous case, and basically we can't always know the definite answer. Now, sometimes only one of the angles works. So maybe this 172 would be too big, and then the first quadrant answer would be your only answer. But we're not going to get into that. I just wanted to show you there is a reason that we're not solving for angles with law of sines, and that's because it kind of brings in this kind of complicated issue. So the main point of the lesson is just solving for angles with law of cosines, and we'll see that when we solve with law of cosines, we only ever get one answer. So here's our first problem. I used this weird little square thing to mean the measure of angle T, just to show that in this lesson too, in Delta Math, there's some spots where it's not going to show correctly. So I'll draw out my picture, my triangle. We have triangle TUV. So I have that side T across from angle T is 69, U is 74, and V is 14. Okay. I'm finding angle T. I don't really like using T's in my equations because they look like plus signs, so I'm just going to put an X here. So looking through this picture, I don't have any side angle pair I know, so I know that means I have to use law of cosines. And I'll write that out again. A squared equals B squared plus C squared minus 2BC cosine of A. So my pair that I can plug in for my a's is right here. So I'm going to put those in. I'll write it down at the bottom so I have a little more room. So my side A is the 69. My angle A, or in this case angle T, is the x. Okay, so you'll see with these, the x ends up being with the cosine, so they're a little bit harder to solve. So I'm going to plug in the other parts. So I can randomly pick 14 or 74 to go in for B and C. I'm going to do the 14 first, just because that's what I picked. And then I have 2 times 14 times 74. Now, in the other problems we did the other day, I could type in this whole right side of the equation, but I can't now because this piece is not like terms with the other parts because it now has an x there, or cosine x. So I'm going to type in what I can. So 69 squared is 4,761. I'm going to type in these two together. So that gives me 5,672. And then I can type in this piece of this term, and that's going to give me negative 2,072, and then cosine x. So remember, I still can't combine those two numbers together, so my next thing is just going to subtract and divide. So I subtract 5,672 from both sides, and I get negative 911 equals negative 2,072 cosine of x. So my next step is just to divide. And I get that make a little line here, cosine of x equals approximately 0.440. Now, just like when we did that last problem with law of sines, we do have to think about where cosine is positive when we solve for the angle. In case you didn't realize it yesterday, I never talked about this because we were looking for sides. We never had to do inverse sine or cosine, so it's only when we're finding the angles that we have to think about ASTC. So cosine is positive in quadrants 1 and 4. Now, the reason that we can use law of cosines and always just get one answer is basically because we can't ever fit a fourth quadrant angle in a triangle, right? No angles between 270 and 360 are ever going to fit in triangles. So even though we really have two answers, we're only ever going to have one answer. The same thing will be true if we're in quadrant 2 or 3. If the cosine is negative, only the quadrant 2 angle would fit because the quadrant 3 angle would be 180 to 270. Okay, so could have two answers, but they will always not work in a triangle. So next step, cosine inverse of 0.440. Remember, keeping the whole decimal. I didn't say what to round to on this one. We're going to go nearest degree. So this ends up giving me that angle is 64 degrees. Okay, so we're going to look at one more example with this. So in this problem, we have triangle ABC. We have that C is 25, A is 12, and B is 17. And I've said this a bunch, but my picture is obviously not to scale. That's fine. We're just trying to find stuff. So we're finding the measure of angle C. I'm actually going to put a little C here. We'll use the letter that goes with the side this time. And I'm going to write down my law of cosines because I see that I don't have any known side angle pair. I don't have an angle on the side where I know both of the values. But I do have this pair where I'm finding something, and that will work well with law of cosines. So once again, I did one where we use the same letters that are in the formula, but we're not going to be able to plug them in directly. So just to write this out a little more intentionally this time, really, because I have C for my ones that I want to plug in, I'm really doing C squared equals A squared plus B squared minus 2AB cosine of C. So the whole idea here is, unlike Pythagorean theorem, and I know this one kind of looks like it, all of those letters are interchangeable. Okay, I just have to keep, if I move C here, I have to also move C here, and so on for A and B. So plugging them in, side C is 25, Side A is 12. Side B is 17, so we'll put those in these two spots too. And so we have the cosine of C. And yeah, I'm going to change that. I don't want to use C because it's going to be confusing with cosine. So I'm going to make it an X. I know I said I was going to keep it, but I changed my mind. So we'll type in the parts we can, right? We're solving for X here, so we can't type in the whole right side of the equation. So this is going to give me 625 equals 433 minus 408 cosine of X. And then we will subtract. And that gives me 192. And divide. So now I'm going to have the cosine of X equals negative 0.470. So thinking about ASTC, and as I said, I don't really need to, but we'll just kind of hammer home the fact that we really are, but it ends up not mattering. We have cosine equals a negative number, so cosine is not positive. It's negative, so I could have answers in quadrants 2 and 3. Quadrant 3 will never fit in a triangle because it's greater than 180. Now, before I was having you change this to a positive to find the reference angle, which I can do here. So I'm just going to type this in. That gives me an angle of 62 degrees. So putting that in quadrant 2, 180 minus 62, okay, equals 118 degrees, which is my answer. But I could just, and I don't have a lot of space, so I'm going to erase something. I could just directly, I'm going to erase the bottom of this problem. I could just directly type in cosine inverse of the negative 0.470, and that would give me the 118. And that's fine because don't really have to find a reference angle because I don't have to put this angle in multiple quadrants. So either way, the old way or just type it in as you see it is fine.